question 2 from the topic 2.3 questions from the textbook that I asked you to do. So here we're looking at a man slides a box of 50 kgs at constant speed. Now this constant speed is really important because showing that the box is not accelerating up an inclined slope to a height of 2 meters. The slope makes an angle of 30 degrees with the horizontal, and it takes him 4 seconds to reach the height of 2 meters. A constant frictional force of 250 newtons acts on the block. So it's important to understand, I hope I'll be able to, the situation carefully here. So we have something like this. We have a box, and takes it up a certain height to 2 meters above. Now the force is acting on this as the box is moving. Sorry, my diagrams are terrible, but you've got mg down like this. This angle is 30 degrees here. This is 30 degrees. So if I draw this in here, we're going to have a triangle something like this. This angle over here will be 30 degrees, and this force here, actually just let me redo this here. I'll put in this is mg over here. This force down here is actually going to be mg sine of theta, and this force down over here, which is mg cos of theta, is actually being balanced out by the reaction force. So we have that force up like that. Again, I apologize for my diagrams here. So we actually get this mg sine of theta acting down here. Mg sine of theta acting in that direction. So we need a force pulling up in this direction over here. Now this force needs to be equal to mg sine theta. We can actually put some values in here, can't we? Because we know that's 50 kilograms. If we say that the g is 10 and it's the sine of 30 degrees, so that's a half. So we're actually going to get 250, that's 500 times a half, 250 newtons. So the force up here would have to equal 250 newtons, plus also there's a constant frictional force of 250 newtons. So it's got to add another 250 newtons to cover the frictional force, to overcome the frictional force. So you're actually going to have to be applying a force of 500 newtons upwards in order to keep this going at a constant velocity, because we see here constant speed and moving in the same direction, so constant velocity. The resultant force acting on this body is actually 0. So the work done against friction, alright, against friction in this case, that's a 250. We see it reaches a height of 2 meters. So we actually want this distance here. So we're actually going to have to say that the sine of theta is equal to 2 over d. So d is equal to 2 divided by the sine of 30. So that sine of 30 is a half. So it's actually 4 meters that this object is going to be moving. So for the first one here, we're going to get work is equal to force times distance. We're going to get 250 times by 4 is equal to 1000 newtons. sorry, not newtons. This is a unit of work, so it's an energy. So this will actually be joules. So it's 1000 joules. Then it says the work done against gravity. Now this is this mg sine of theta. That's the work done against gravity. So it's also 250. So that would also be the work done against gravity. Would also be sorry, my pen's giving me trouble here. Let me just erase that and redo that. So just rub that out. So this is for 1. Boy, my pen's giving me trouble. So we're going to get for 2 the same thing. We'll get also 250 times 4, so that's also going to be 1000 joules. Now it says the efficiency of the man-made slope. So we've got there we have got the efficiency, the useful work that is actually done up there is actually just this 1000 joules, because that will be energy that can be used again, 1000 joules, but you've actually used up 1000 joules, so the total amount that you've used is 2000 joules. So you're going to get the useful, which is 1000, divided by 2000, which would be the total, times 100. So we're looking at about 50% would be the useful work. And then finally the power the man develops to push the block up the slope. Well, we know power is equal to work over time, so the total amount of work that he does is actually 2000 joules from these two things over here, from these two over here, the 1000 against friction and 1000 against the gravity, divided by 4 seconds, so it's actually 500 watts. 500 watts. Okay, and so that's that question. Being able to work with these diagrams is really quite important, so come and see me if you've got a problem with working with this sort of diagram, and we can discuss it further. Thanks very much.